Suppose that two cards are randomly selected from a standard 52 card deck. Part A, what is the probability that the first card is a club and the second card is a club if the sampling is done without replacement? So when a probability is computed without replacement, this means that once you draw the first card, you draw the next card from the ones that are left over. So when you drew the first card, you had 52 cards to choose from, but because we're doing this without replacement, when you pick the second one, you only have 51 to choose out of. So we are trying to compute the probability that the first card is a club and the second is a club. Now we have to decide whether these events are independent or dependent. After I choose the first card, I'm only going to have 51 to choose from for the second card. So the probability of the second card drawn is affected by what the first one was. So these events are dependent. So we have to use the general multiplication rule. The given condition will be that the first one is a club. So that will be event E. And we will have the following. So now let's find the probability that the first card is a club. We have 13 clubs in a 52 card deck, so the probability that the first card drawn is a club is 13 out of 52. Now let's find the probability that the second card is a club, given that the first one was a club. So if the first card is a club, and we're not replacing it back into the deck, this means that now there are only 12 clubs left. And now we need to determine how many cards there are left total. Because we took one from the 52 cards, there are only 51 cards left, so the probability that the second card is a club, given that the first one was a club, is 12 out of 51. Put this in your calculator and round to 3 decimal places, and we get approximately 0.059. Part B, what is the probability that the first card is a club and the second card is a club if the sampling is done with replacement? So we're trying to find the probability that the first card is a club and the second card is a club. Now we have to determine whether these events are independent or dependent. Because we are trying to compute this probability with replacement, that means we're going to draw a card from the 52 cards, look at it, and then put it back, and then draw the second one. So is the probability of the second card affected by what the first card was? The answer is no. When we put the first card back, we're still going to have 13 clubs, and we're still going to have 52 cards total. These events are independent, and that means that we can just go ahead and multiply their individual probabilities. So now let's find the probability that the first card is a club. We have 13 clubs out of 52, so the probability that the first card is a club is 13 out of 52. Now let's find the probability that the second card is a club. Remember that we are putting the card back, so that means we still have 13 clubs out of 52. Type this into your calculator and you get 0.0625.